Okay, I think it's recording. Cool.
Yeah, so welcome to workshop 5, Solidity continues. So it's pretty much going to be an add-on from the last workshop. Like we covered some basic stuff last time, and yeah, thank you for showing up. It'll be recorded, so if you miss anything, don't worry. So this is today's agenda. So we're going to start off with just the basic addresses. Mappings require what it is in Solidity, storage versus memory, data location, interacting with other contracts, using an interface, and handling multiple return values. So we're going to start off with addresses. So that's just straightforward. I guess we covered that already. It's just pretty much an address or like a bank account number, pretty much. So you can then define the unique ID to represent the ownership. And it could show you how much ether that person has. Next, we're going to go to mapping. So what mappings are, they're pretty much, mapping and SLEs are pretty much like dictionaries in Python or maps in Java, as you probably know. So yeah, so to create a mapping, you guys can see my mouse, right, or no?
Yep.
Yeah.
Okay, yeah. So to create a mapping, you would use a keyword followed by a key type, and the key type has to be a built-in value type, so it could be a string or a byte or a unit. So in this case, it's an address, and the value type could be anything as you want. And this is the mapping name, account balance. And then for this one, it's just, I guess, it's storing a string, and the key type is a unit, and it's called user ID to name. And it pretty much will take around an O to what is this? Big O.
Big O of one.
Yeah,
So it's
big
like
O one.
yeah,
Linear time.
yeah.
Yeah. Yeah. So
It'll always take
right.
Constant
at
time.
most one,
Constant time.
yeah, at most one operation to get there.
So yeah, that's mappings. Next we go to require. So think of this could be used as validation. So if the condition is true, and then it'll do what it is. And then if it's false, could throw an arrow or revert the transaction. So in this case, it's a function get into the bar, takes in two arguments, and then returns a type string. So the require for here is if the age is greater or equal to 18 and the name is not Chad. So if the person's name is Chad, it would throw an error. But if this doesn't actually, if this is false, then I mean, if this is true, then it will return shot, shot, shot. So yeah. So think of it as like a validation, like in an if, like a kind of condition in Java or other languages. So yeah, I'll pass off this to Teddy now to further on.
Sure. Sounds good. So moving on, we have the notion of inheritance, and that's essentially when kind of like how classes have inheritance for object-oriented programming, you can also have inheritance with Solidity, which is great. So for example, in this in this example, we have our parent contract, which is just like a casino game, but it's very general. There's a winner and a game ID, and it also has a function called get winner that returns the winner essentially. And what I can do is I can create a kind of specified version of that contract called blackjack, and I can make it inherit the casino game contract. So what that will do is in the blackjack contract, I'll get the winner, I'll get the game ID, and I'll also get that get winner function, which is great if you're kind of coming from an object-oriented background. This is really good, and also kind of cleans up your contracts a little bit when you're writing them, just so you don't have anything in one thing and you can kind of generalize it a little bit more. Yeah, that's the next one. So we also have the notion of import statements. So for example, if we had those kind of two files, we had the casino game and the blackjack contracts, and we didn't want to put them in the same file, what we could do is you can put them in separate files. And then, for example, in the blackjack contract, we can just write that simple import statement. So it'd be import casino game, and then you can use the same inheritance that we used before. And also what you can do, I believe with some open source contracts, I know with Remix, you can import like OpenZeppelin open source contracts directly. So you don't have to actually have that copy of like a publicly tested contract. But but I'm not 100% sure of that. I think you can do that. Next one. Yeah, so we kind of touched on this a little bit last workshop, which is the notion of memory variables and storage variables. And so we'll this kind of be a refresher. So what storage means is that these are variables that are stored permanently on the blockchain. So if you specify a kind of a contract global variable as storage, or even if you declare it within a function, then it will be stored on the blockchain forever. It won't get thrown away, and it won't make a copy of itself. Whereas memory variables refer to temporary variables. And so you would typically do these with function calls. So what the function calls would do is they would make a copy of the variable so that you're not actually changing, unless you specified with the storage keyword, you wouldn't be actually changing the data in the address. Yeah, so it's similar to how a computer's hard disk, where you have persistent memory all the time. Even if you shut down your computer, you'll still have that memory there, compared to RAM, where if you shut down your computer, you won't have the memory there in RAM once you restart it. So it's kind of similar functionality. And in terms, Solidity will handle declarations by default. State variables will be default as okay, so contract state variables you don't need to specify them. So for example, we had that like winner variable before in a previous contract, that's automatically declared as a storage variable. So that will automatically be on the blockchain forever. And then variables that are declared inside a function are automatically assigned as memory. And you can change this by putting in those memory and storage keywords. If, for example, you want a contract variable to only persist in memory, then you can do that. And in a function, if you want it to persist in storage, you can do that as well. You just have to explicitly specify that. And the next one. Okay, so here's kind of an example of kind of what we've talked about, the storage versus memory. This topic that we've talked about this workshop and last workshop. So here we have a contract called Bike Factory. And essentially what it's going to do is going to create bikes for us and store them in this little array that we have. So we have our struct there. Our bike has color, brand, the value of the bike, and the status of the bike. And the status can either be bought or it's been sold. And we have this array that stores these bike structs. And this contract has one function, essentially. And so we can look at it. We can create our bike by, okay, so we don't have the function there, but just assume that this bike array is already filled up. And so we have this function called buy bike. And so we want to buy a bike from this array. If we declare the bike that we get from this array as a storage variable and we change the status to bought, then that will change that bike variable in the contract, essentially. So it will it'll essentially be pointing to the address where that bike variable is being stored. Whereas if you look at bike memory, bike numero dos, so the second bike, we're looking at the next bike in the array. If we change that to sold, that actually won't modify what's in that global bike array. That's just going to change the copy of it. So it won't actually do anything. So what we need to do on the last one, and the last line you can see, is actually change that entry in the array to our copied entry, so that it maintains that edited status. So that's kind of explaining a little more practical example of storage versus memory. Next. Yeah, so the next thing we can do now is we can actually interact with other contracts on blockchain, which is great if you want to implement some functionality that you know that other contracts might have. So yeah, for an example here, I have a contract called Lucky Number, and it's just a mapping of, it's got a mapping of numbers, of addresses to numbers, and so the addresses will signify like a person or a wallet. And you have a set num, so someone can set their number to their lucky number, and they can also get their lucky number from this contract. So for example, let's say this contract's been deployed. and we want to just use that get num function. So what we can do is we can actually create this interface. You can see it's called number interface, and it's just got one function, and it's got the get num function, but we don't actually declare what it does. It just knows that that function needs to be there. And what you can do is you can take the address of where that lucky number contract is stored, and you can put it into that number interface, and then it'll kind of be talking to that contract via that interface. But it's not as bloated as the lucky number contract because it only has that get num functionality to it. So, and like the way that it knows that it's an interface is that the function declarations don't have any actual body to them. It just has a declaration. So Solidity compiler will get that from that. Yeah, so kind of continuing on. So like I mentioned, let's say the contract was stored on, let's say the lucky number contract was stored on, ABC123, and we wanted to create an interface of it. So we would pass in the address to that number interface that we made before, and then we would implement this a get favorite number of address from an owner, and then we can return the because we have that get num function from our interface, we can actually get the number back. And so the interface essentially is kind of a working copy of that lucky number contract, but it's much less bloated because you won't need all the functionality. So it's common. You'd probably use this with some open source libraries out there to implement something like an ERC20 token or an NFT project or a DAO project where you might not need everything that's in those contracts, but you can pull things out from where you want them. Yeah, as long as those functions, yeah. So the functions that you're calling, they need to be exposed using a public or external keyword so that you can actually use them. If it's a private or internal, that means we can't really touch it because that's only within that project or that contract. Yeah, that's interfaces. And then kind of one last thing we want to talk about is kind of, some programming languages don't allow this, but Solidity does, and it's handling multiple return values. So these are just a couple examples of how we can return multiple values. So the first one is pretty simple. You can just return a tuple, and you would declare that as well in that function declaration. And then so if you actually call this function, you would call it using that second way to do it. So you would wrap your variables inside brackets, and then you would call the multiple returns. Or for example, if you wanted just the last one, then you can just write commas. You don't have to declare anything else, and then declare the last one and then call multiple returns. And that's as simple as it gets for return values. But yeah, I think that's it for our kind of advanced or kind of more basics on Solidity workshop. I think there's a final slide there where Perry or Paul will take over.
Yeah, so this is pretty much our last workshop for the semester. So thank you for everybody who ever watched these. So these are the timeline for the next semester, kind of. It's all rough, so it's not all confirmed yet. So January, we're pretty much leading up to Club Week. We'll probably increase our advertisement for that, and then some panel event possibly. Leading to February, we'll do some project development mostly, and then we're thinking of doing bi-weekly crypto and coffee kind of thing. So it'd be not just for people who are like into development. So it'd just be like we'll get a classroom, have some food there, and then we could just talk about crypto stuff and NFT stuff maybe if you guys like. And it would just be a get together to get closer to our club members, closing the gap between the execs and our members. And then March is pretty much hopefully project showcase possibly, and then some social events. And yeah, so you guys have a great break. And if you guys have any questions, just let us know. If you guys have any add-on, Paul, or
no, I think you guys really hit it. Yeah, that's all for us, I believe. Thanks for coming.
I just close the recording.